Hello, everyone. Thank you for being here with us. As mentioned, I work with IOLAB, currently on a position of Application Managed Services Team Lead, and as mentioned, with pretty big DBA experience so far. This presentation will not go into too many technical details because migration on its own is a very complex thing. It will give you an overview how this process should be done and what are some of the key steps you should take. So here's the agenda, and of course we always have to have some motivation why we want to do this. So usually money is always best motivator for everything, and in case of migrating to Redshift Cloud, you're going to see a big reduction in your TCO. Two main things here are no on-premises cost, meaning you don't own hardware anymore. No cost of maintaining that hardware, no huge electric bills, because if you have experience, for example, Netezza appliance, you know that thing needs at least 8 kilowatts of energy 24/7 all year long. So that's going to be a significant cut down in your expense. One other thing is pay-per-use, meaning you don't buy something you will need in 5 years from now. You buy what you need now. And when that changes, so will you. So those two things will automatically be a big cut down in your expenses for your company. Another big thing is scalability. We all know that business can change, and it will change. Maybe it's going to scale up, maybe it's going to scale down. And with Redshift, you are able to follow that change. You can easily scale up or scale down, and basically you can follow your business as it evolves. Another big thing is flexibility. Today, we all know we don't have time to sit down and do your work from one place, and with Redshift and Cloud, Amazon Cloud itself, you're able to be on move. You can work from car, you can work from anywhere, basically, from any device. All you need is internet access, and I believe that's not an issue anymore. And also, one other very, very big thing is being hardware agnostic. That means you are not chasing all the latest in the hardware world because you'll purchase that from Amazon if you need it. So basically, you need a laptop, iPad, mobile phone, and you're good to go. And regarding the flexibility, another thing is you can move your entire company without impacting your business system. It's in cloud. It's not paired with location. You can take your business in another country, in another city, and it's not going to have any effect on your business because you're flexible. So let's compare two systems. Netezza is a very well-known database appliance, and I mean, there is no perfect solution. Each of them have some pros and some cons. We all know Netezza is very fast, but it's terabyte scale. It deals with updates, deletes very fast. It works best with structured data, and it has a pretty good data import-export options, even already canned in Netezza itself. You can move data between Netezzas in a matter of few clicks. With Redshift, you are petabyte scale. Actually, you scale as up and down as you want, as you need. You're in cloud, so there is no need for huge administration. Redshift is a columnar base, so data analytics, data science is much more easy to apply on this system than it is on Netezza. And we all know today data science is something that everyone wants to have in their business. It is also very fast when processing small amounts of data as well as huge amounts of data. So that is one of the very crucial things for Redshift. Cons, well, yeah, it's based on a bit older version of PostgreSQL, 8.02. Migrating data can be a bit challenging. There are no canned solutions, no buttons to press and data will be migrated. And it does not support store procedures. And whoever works with data warehouse, I know you all love store procedures. I know I do. So, but like I said, those are all things we can live without because we can find our way around those potential issues. So, migration patterns, 3 of them: rehost, refactor, replace. And I know everybody loves the first one, where you basically take whatever you have in your on-premises system and just place it in the Redshift, and it works. It doesn't happen too often, but you can do it. Refactor is something that is more often used because you leverage the solution you already have, but you need to do some adjustments to it in order to fit in the new architecture into new system that you currently own. And the last one is replace, where basically the solution you already have simply will not work in Redshift environment, and you'll have to create something new. Probably you're going to utilize other Amazon solutions or technologies that are available to you. So basically you'll have to replace whatever you had there with something new, something that's going to give you probably much better performance than if you took whatever you had and tried to force it to work with Redshift. Before you start, now this is a very important step, and people usually don't spend enough time on this. Conduct a deep dive data warehouse analysis, because you're going to find a lot of unused objects, unused tables, store procedures, functions. All that needs to be removed from your system, because automatically it's going to reduce the amount of work you'll have to do to migrate your data warehouse into cloud, into Redshift. Analyze your data. Usually we say there is hot data, warm data, and cold data. Hot, it's being used on a daily basis for your business. It's being exchanged on a daily basis. So touching that data is definitely going to have impact on your system. So you have to plan carefully how you're going to be moving that data. Warm data is similar to hot, but maybe it's being done or touched on a weekly basis, monthly, or even some kind of a quarterly basis. And there is cold data, basically your historical data, something you will probably query from time to time, but most likely you're not going to be changing that data. Determine compatibility. So take your system, compare it with Redshift, see how much those two are compatible. Data types, data distributions, functions. Because if there's something that is not compatible, or even if it is, maybe you can find a better adjusted solution, something that's going to be better for your system in Redshift. Also, identify all other elements of your system, because you're not just moving your data warehouse. There are reporting tools, reporting applications, custom-made web applications. So make sure you have identified all the elements that need to move together with your data warehouse. And create timeline. This is a very important thing. So you did the analysis. You know exactly what you need to do, how much work you have. So put it in a time frame. Create your key steps or milestones and be dedicated to it. Follow those steps, because you're going to easily lose track. First step in your migration is going to be to migrate schema, of course, because if you don't have schema, you won't be migrating anything. And here, AWS created a very great tool for you. It's called Schema Conversion Tool. It is suitable for relational schemas. It is suitable for data warehouse schemas. It is very intuitive, very easy to use. On the left side, you have your source. On the right side, you have your target. In this example, I don't know if you can see it, it will also, during this process, tell you if it detected any issues, any things that are not compatible. So it's automatically going to tell you where the problem is and how to solve it. And once the conversion is done, your new schema is already implemented into Redshift and it's ready to be used. Now, how to migrate data. Now, this part is a bit challenging, always, especially if you have 20, 30, 50 terabytes of data. For this purpose, Amazon created database migration service. Basically, what it gives you, it's option to stream your data from on the premises into your new Redshift cluster. But You're also going to need AWS Direct Connect, which is a dedicated network between your on-premises network and AWS Cloud. It's not an ordinary network because it is stable, it is content, it is up to 10 gigabits per second. So without that, streaming is not going to be very efficient. And that's where you will find Snowball and Snowball Edge. There is also a thing called Snowmobile, which is literally an Amazon truck that's going to be parked outside your company. What is it? It's literally an external storage. Why would you use external storage if you have data migration services? Well, it doesn't work always. That's why there is at the bottom plan for issues. For example, currently Netezza is still not supported as a source database, meaning you'll have to come up with your own solution how to export that data into Snowball, Snowball Edge, or if you really have a huge company, then probably a Snowmobile. You have a lot of options there. Maybe you'll utilize ETL tool, maybe you are good at bash scripting, but yes, that's why I said here plan for issues, because data migration is never an easy and smooth thing. Because maybe everything's going to go fine, but you'll find yourself with the corrupt data. It happens. Something in the export process failed and your data got corrupted. Or if you ever did the migration, you know, when the import tool says UTF-8 issue. Yeah, we all love those UTF-8 problems. So when you have it all sorted, also what we usually do, we start with the cold data first, because you can start exporting that data without having an impact on your current working system, because this is all happening while your system is still online and being used, because you cannot shut down your system for, I don't know, 6 months. This is all happening in parallel while your business is up and running. Migrate processes. Now, here are a couple of examples. So usually you see ETL tools, you have, and you've heard about today a lot about AWS Lambda. There's a great tool called Luigi. Don't know if anyone heard about it here. Anyone? Cool. And Python. By all means, these are not the only way how you can deal with your ETL. It just, these are most often used. On the left side, you can see some of the elements you should consider when dealing with ETL. Cost, is it modular? Is it integrated with AWS? Is it easy to use? Is it scalable? And how complex it is? ETL tools are great. Usually, we all have developers who are dealing with talent, informatica, data stage, a number of ETL tools. But they all come with an issue of cost, because you have to purchase licenses, and those EC2 instances are not going to be some small EC2 instance. It's rather going to be a bit beefy instance to deal with the ETL itself. But it's going to be very easy to use. AWS Lambda is great if you have a bunch of Java developers, C# developers, Python developers, because they'll jump right into it, because they're going to use Lambda just for orchestration. If not, probably not the best way for you to go. Luigi is a great tool. It's easy to use. It's Python-based, but it doesn't have a huge learning curve. And basically, you can use Python as a wrapper for your SQL code and Luigi to orchestrate it. It's easy to create complex workflows, simple workflows. It has a good visualization of what is happening with your data. It has good issue handling. If something got interrupted, it makes note out of it. It knows if it has to be rerun or just restart the entire process. So it's a really, really great tool. It's free. And the EC2 instance that it's going to use can be a small EC2 instance because it's just running a Python code. And like I said before, if you are great with Python, you have a lot of Python developers, then yes, by all means, use Python because, again, it's a free tool or language. It's going to need a small EC2 instance, nothing too heavy, so it's going to be very, very cost effective. As far as reporting goes, usually there is not too much work. I'm not saying it's just repointed to another data warehouse. Some adjustments will probably have to be made, because if you change your DDLs or a bit of that structure, you have to do that in the reporting tool itself. But usually it is just about setting a end date. Okay, we are pointing our reporting services into a new data warehouse, do some of the fine-tuning, and we're good to go. And last but not least, now that you moved into a Redshift environment, how are you going to manage that environment? Here I would suggest for everyone to utilize code commit. So basically, code commit is a Git repository from AWS, and you should store everything in that repository. If you did your ETL with Python, with C#, Java, even if you did it with, for example, Talent Studio, all that can be stored in your Git repository, because it's going to give you version control, it's going to give you ability to share that code easily with rest of the, groups in your company, different segments of developers. So everything is much easier, and more than everything else, it has that version control, because maybe someone did some change he shouldn't be doing. Well, let's just go back. Another thing is create good maintenance plan. I know I said before that Redshift is cloud-based, it doesn't require a lot of administration, and it doesn't to be operational, but this maintenance is for data. So you have to have a good plan. How are you going to be maintaining your data? You're going to be performing updates, deletes, and all that requires vacuum. I don't know if you heard about it, probably yes. Because without executing vacuum regularly and analyze as well, you're losing all that table statistics. With bad table statistics come bad query execution, comes very bad performance from your new system. So these are some key things you have to have in place, and it has to be executed regularly. Daily, weekly, monthly. It's going to depend on your system. How often is your data being changed? And based on that, you're going to create your own maintenance plan. Monitor and optimize, those two absolutely go together. And you can see on the left side something called Redshift Web Console. This little tool gives you all the information you need about your system. You have database performance, how are your queries running, are they queuing, are they losing too much time on writing data, how is your cluster performing, is there a CPU utilization too high, is the disk I/O too high, what is happening with my network, am I sending too much data out of AWS because that's expensive. So all that information you can find in your Web Console. And in pair with Web Console and metrics I've just mentioned, you have something called CloudWatch. There you're going to set up all the necessary alarms for your DBA to know, for example, my CPU went over 90%. Alarm. Something's not right. My disk I/O is too high. Okay, something's not right. I'm killing my system. So those two come always together. And from this information, you're going to start your optimization. Basically, if I'm seeing that my queries are writing too much data, that means something needs to be changed. I don't need that much data each time. So you'll be able to optimize your SQL files, your Python code, even your tables. Maybe you are using wrong distribution key, so it's not performing as well as it should. Maybe you're using wrong compression. That can happen as well. So maybe you need to optimize that. Maybe your workload management is not very well optimized, because that can usually be the first thing that's going to create bottlenecks. So all this has to be done on a daily basis, on a monthly basis, and that's basically what you have your DBA for. Questions? I know this was a very high-level overview, and believe me, each of these steps could be a presentation on its own. So please feel free Any questions?
So Redshift is based on Postgres base code, right?
Yes.
And the question is, so Redshift is basically distributed version of Postgres, if I understand it correctly, right?
Yeah, it's using the version 8.02.
Okay, but data is distributed by something, by key, by certain, for example, primary key across shards in a cluster.
Exactly.
Yeah, okay. And also it is using the columnar storage, if I understood. But is it using real columnar store, or is it basically some kind of columnar store?
It is columnar store.
It is. So
Yeah.
basically it's not using classical heap as casual Postgres uses.
Yeah, I mean, it's a kind of a hybrid.
It's hybrid, okay.
Yeah, and that's why you're usually going to see that update statements are going to take a bit longer than they would, for example, on a TISA, or
Okay.
those delete statements.
Okay, thank you.
Any other questions? Go ahead.
Hi, Davor.
Hey.
Thank you for your presentation. So one question, you mentioned store procedures in Netezza. So how did you manage to migrate store procedures into Redshift?
Yes, so like I said, store procedure is something that every on-premises system usually has, and they are one of the best ways to manipulate data, especially large amount of data. So what we did in this migration, or basically in all the migrations, we used those SQL files just like that, as a SQL files. We stripped everything related to a store procedure, created separate SQL files out of them, and then we used Python as a wrapper combined with Luigi, and basically we again have store procedures. They're just not being called store procedures. But yeah, you can, that's the good part about this, because you can reuse almost 90% of the code you already have. Some adjustment will have to be done because you're, like I said, it's a PostgreSQL 8.02, so some functions will be missing, and you'll have to find a better or suitable replacements for them. But yeah, basically you can reuse almost 90% of the SQL files, SQL code in those store procedures, and use them via Python, via Java, or some other language you feel most comfortable with.
Thank you.
Anything else? Well, if you have any questions, I'm here. Feel free to ask me anything. Maybe if you have some specific questions or details, by all means. Thank you.